Alright guys, in today's video I've got a Craftsman belt disc sander, 2/3 horsepower, that somebody has brought to me. Looks like a 4x36 inch belt and a 6-inch disc. And this is, asked me if I can get it working for them. This particular one is a model number 137.215360. I think there's a couple others that are very similar to this. I'll put in the description below, but basically we've got a problem with the motor here. If we get some of this stuff out of the way, of course, it's all covered with sawdust. But if we turn this guy on, if you get close enough here, you can kind of hear it's kind of buzzing. You can watch this belt here. It'll start to try and go. So problem with the motor, could be just all gummed up with sawdust from the looks of it. The first thing I'm going to do is I'm going to take this out behind the shop out in the grass and get some compressed air on here and just blow all this stuff off. Don't want to create a mess out here on the drive area, but we'll come back and then we'll see if we can disassemble this partially enough to see what's going on with the motor. So guys, we've almost got this done. The bulk of it is out. I'm just trying to get pieces that might be trapped down inside the belt here. This is all you need to do. Just blow all this out, or all around the corners, all inside the grills on the bottom. As soon as we finish this up, we'll start taking it apart. Alright, we blew probably decades worth of sawdust off of this thing. When you turn it on, it tries to crawl a little bit, especially if you kind of give the motor some turning. You can see the belt moves a little bit, but otherwise it just hums. So we still have a problem with the motor starting. So this model here, this 137.215.360, I couldn't find a manual for this, but I found one that looks very, very similar, which is a 137.283.290. Same dimensions. Externally it looks identical. And just taking a quick look at the parts explosion, it looks really almost the exact same type. So there might have been several of these from different suppliers or something of that nature, but I think we can use this to do our disassembly. So what I'm looking at here is I just want to kind of get into where the motor and the pulley go, which are associated with this disc part of the sander right here. So what we're going to need to do is kind of reverse the assembly. This is when you put it out of the box. They talk to you about getting everything assembled. I'm going to kind of have to start at the end here, pull this piece off here, pull this sticky sanding piece off here so that we can remove the plate, and then we can get this upper shroud out of the way, and that should expose the belt for us. Then we can get the belt off. We can see if we can get the motor to spin freely. So we're going to go ahead and pull the power for this part of the exercise. And then let's go ahead and lift her up and get that cover right here off. It's held on, looks like, by a Phillips screw here, or it looks like a combo screw. It could be a Phillips or a flathead. Let's take that off and see if that reveals the full plate for us, the way the diagram suggests. Looks like this vacuum piece here has seen better days. Alright, good. So now, right behind this plate, inside here, this cover here, is where the belt is. We got to get this plate off. To get this plate off, looks like we can adjust this little table here. I'm guessing that's what this screw is. I didn't actually see anything in the manual, but it's kind of obvious. Yep, so we can kind of get this guy off. Alright, so now we need to peel off the sanding disc in order to remove this guy. That should be fun. This has been on here for a very long time. But maybe we can just cheat. Get access to the little set screw in the middle. Alright, so I see something here. Now, according to the manual, what we should be seeing So this is probably the shaft that's protruding. And then there's a set screw that holds it on that's accessible through a slot here. Insert a hex wrench down through the slot in top of the belt and pulley guard and tighten the set screw. So we should be able to reverse that process and get this guy to let go by putting something right down in here. All right, let's see if we can get this guy off now. I'll show you what it looks like. We go down that little slotted hole there. And if we get the light just right, you can see that spindle right down there. If I rotate this guy around, we should see the set screw right there. He is, right there. Right, so that, if you can pull the camera out of the way so I can get this in here, we're going to go in here with a 3mm Allen wrench. Looks like it might be it. There it goes, just pop loose. That should be enough to get this guy off of here now. Probably have to overcome a little bit of corrosion, I guess. But if we look in the manual here, that should be the only thing holding this on is that set screw. Can't really prise on this plastic because we might break it. But I think what we got going on here is it's just corroded onto the shaft a little bit. I feel it moving, but I don't feel it coming off. It moved a little bit more out. There it went again. Come on, baby. The owner was telling me they bought this sander from Sears back in 2004, so this has been sitting on there for 20 years. It's bound to be a little stuck, but as you can see on the front here, we've gotten it to come off about halfway. So I'm going to squirt a little bit of penetrating oil down there and see if we can work it off the rest of the way. All right, so now we push that back in there. There we go. Come on, baby, just a little bit more. That's interesting. Looks like somebody lost an X-Acto blade at some point. Just going to have to work it off the last little bit here. Not sure why it's so stiff to remove, given that the set screw is completely removed now. Let's see if we can get in there and see what's going on. Yeah, the set screw actually fell out and is laying inside the cover piece. There we go. There's the set screw right there. You never want to force this kind of stuff because you never know what might break. All right, now with this out of the way, let's see, this screw here might be the one holding this cover on. Let's see. And one up on top. All right. So there's our motor and our belt, along with some more really old and dried up sawdust. There's our motor right behind there. So she's obviously not bound up. She's spinning freely. What I want to do now is I want to get the belt off. So if we again consult the manual and reverse the installation. So we've gone here, here, here backwards. Now we're here. You can see here it's talking about adjusting the belt with these two hex bolts here. So if we release the tension, yeah, this one's not even held on. Got a smaller guy here to fit in this side. Is that the belt or... yeah, there she goes. I don't want to replace this belt, so we're just going to try and work it off nice and slow. All right, now the belt's off. Not really sure that those bolts are moving far enough here. Loosen the two hex screws. Move the sanding arm to the vertical position. We should have did that, and that would have made it easier to remove. All right, got it for next time. All right, so we got what we wanted to do, though. We have got it where we can spin this guy freely, and it spins nice. No resistance at all. Let's see what happens if we try to power it up without the belt on. All right. So our motor's fine. So our problem is not the motor. There's something bound up here. So as the motor tries to turn this gear, something's bound up here. All right, so let's disconnect the power again, and I guess the next thing we're going to want to do then, let me read up here. I don't think this is going to be covered in the manual because you weren't supposed to touch this. This would have all been pre-assembled. And so all it would have been is talking about various adjustments to changing the belt itself. So let me try to study the parts explosion here and see if I can figure out. So, we removed this plate with this attached to it, this cover, and this belt. And here's this pulley. This pulley right here is this one right here. So we're going to follow this diagram back, and we're going to see what we need to do to remove this piece here so we can see what's binding up in here. I mean, if I turn it, it obviously turns, but it could be that it's supposed to be turning more freely, or it could be that we still do have a problem with the motor. It could be that the motor is able to start with no load, but can't start with a load. So, I guess I shouldn't exonerate the motor just yet. It just means I can probably feel like we probably don't have a short on the windings, or it wouldn't turn at all. So let me go study this and we'll come back. All right, first thing I'm going to give a check is on this belt tension adjustment. So we already loosened these two bolts, and they told us to move the sanding arm to the vertical position, but then tighten those two hex screws. So we're going to move this guy up here, and we're going to tighten these two. This one, it's just to see if maybe the belt tension is something to do with the behavior we're seeing. All right, and then it says loosen the lock nut number 3. If we look at the diagram here, there's a lock nut and a screw here. Loosen the lock nut and belt tension set screw by turning it counterclockwise. All right, so let's loosen this guy. All right, so that's loose. Raise up on the motor pulley to replace or remove the existing belt. Place a new belt on both pulleys. All right, so if we end up having to get a new belt here, I'll show that. But for now, we'll just try to put the old one back on. And with this guy loosened up, we're able to lift up on the motor. So I guess that is how they actually intended this to work. Loosen up on this a little bit more. I'm just trying to get it into all the teeth. All right. And then they would have said, at the center span of the pulleys, apply light pressure to the belt. At the same time, tighten the set screw. Okay, yeah, so as I tighten this down, I can feel the belt getting taunter. So I want to loosen it up a little bit so there is a little bit of play in it, because it is an old belt. We'll hold it right there, and we'll retighten this lock nut that holds it in that position. I don't think this is the problem, but it was worth checking. All right, now with that done, reapply light pressure and maintain belt tension to be between 1/4 and 1/2 inch deflection. Right, just like that. I mean, we could get out here and put a ruler if we wanted to, but I can tell that that is close to 1/2 inch. Important, do not over tighten belt tension because it does not require excessive tension to function, and excessive tension will reduce the motor and belt life. After it's obtained, tighten the lock nut. Done. And position the sanding arm in the horizontal position by loosening those 2 bolts and retightening them. Okay. So we'll loosen these 2 guys again. We'll bring this guy back down, and then we'll tighten these back up. And we'll see if this had any bearing on it at all before we go any further. All right, let's power it back on. Yeah, so she just doesn't have enough power to turn this. And it's not because our belt is too tight. So I don't know. I really don't feel like there's enough friction in this sander piece to be causing the problem. There's a piece here that loosens our tension on the belt so that the belt can be changed. And I think what I want to do now is I want to take this sanding belt off and see if it can turn this assembly without the belt here in place. So let's take a look at the manual and see how we get this guy off, and we'll give that a shot. All right, to get this belt off of here, there's a section on that. You got to remove 2 screws that hold the dust chute. There's a single bolt that holds the backstop. With those 2 pieces removed, we can move that tension lever, this guy right here, to the front, take off the tension, and then we should be able to remove the belt. So let's do that now. Just going to stick with our adjustable wrench here for this, if I can. Looks like the previous owner has had this off before. Not sure why there's so much tension on this guy. Okay, there's that backstop. And then There's the two screws they were talking about. Looks like one is original and one has been replaced. Probably do not need to take them all off, but could just slit it out probably. Like that. Let's take this other guy before we lose him. Put him back in there. Alright, and then slide this and take the belt off. Alright, now let's see, without the tension in the belt, can the motor turn this assembly? No. So that kind of makes me feel again that it may actually be a motor problem after all. As you can see, there's no tension at all up here. This is really easy. Really easy to turn. Just turning it with 2 fingers. Alright, so I guess we're going to proceed to take this plate off so that we can access the motor and see if we can see what's going on there. Alright, I went ahead and took this belt back off again. You know, this is spinning really freely. I mean, there is a bearing here, but I don't feel any vibration or grinding or anything. It's not making any odd noises. So I really suspect down here. So I'm going to pull the power off again, but I'll show you. It still comes on. Although with the set screw all the way out, it has a little bit of a vibration. But otherwise, it's still behaving the same as it was. So we'll disconnect the power. And then we'll take this front plate off. Just want to see what kind of motor we've got here. This is going to be one of those kind of things where, you know, it's too old for there to be any spare parts. So either we find something easy, and it's not going to be, I don't think it's the capacitor because the motor obviously starts, but it could be one of the windings is shot. Or we have to find somebody, you know, selling one they're parting out if we needed to get a different motor. Alright, so maybe we want to take off this little cover here. Since we don't have any instructions, we're just going by the parts explosion. Just kind of disassembling everything and exploding it, right? Alright, so we got a couple of ground wires. See if it lets us get the cover out of the way if we take this guy off. Just going to try to get it to stay there so we don't lose anything. Pop this one off too. Okay, our little star washer fell in here. I'll have to get that out later. Our switch, there he is. Put this ground line out of the way. Put this one back in so we don't lose him. And then let's disconnect this guy from that side. And this guy from that side came off nice and easy, so I want to figure out how we put these back on properly. One's wider than the other, so the wider one goes up and down, and the thinner one goes straight across. Did this help at all with getting this loose? It did not. So it looks like we're hung up on the power cables. So we got to get the power cables out of there, but let's just go ahead and keep going. There's another one down here on the bottom, a plate held on by 4 more of those kind of screws, although kind of larger diameter it looks like. Or is it? No, they're the same. There's also another ton of sawdust in here that can be cleaned out. While we're in here, there's our motor. All right, so we just need to figure out how to get the power connector out of this little box. And how is this motor attached? There's the capacitor, bulge right there. I don't immediately see how it's mounted. It probably has some kind of bracket up on top, I'm guessing. I see there's just a random bolt attached here. It doesn't hold anything. Not really sure what that is or why it's there. All right, let me see if we can get the power cable. Let me look at this a little bit more out of the way so we can get down where you guys can see how the motor is actually attached to this cast iron frame. All right, right as I was about to stop, I kind of noticed that if you get it up over like this, it'll just slide out of the way. So we didn't even need to take apart what we took apart there. So now we've got a good view of the motor. There's some kind of like a torsion mount piece that hooks up to that set screw where we adjusted the belt. Right, so that guy is up here on this side, if you recall, right there. And that whole thing here, see, I can move this, is attached to that. Now I'm noticing that this motor, just for the brief time we had it on, is really hot. I mean, I don't know if that's because it's all caked up with, I doubt there's enough sawdust here to be causing that, but maybe if it's all caked up internally, it could be. I want to get it out of here so at least we can give it a thorough cleaning to see if that changes the behavior at all. But I'm not immediately seeing how it's mounted, and of course, you know, they never intended you to change these, so that is not covered in the manual. So I'll bring you back when I see something else, but I just want you to see that you can get this off without having to worry about separating out these power leads. And I want to keep these screws in the threads where they are so we don't lose them. And then we'll come back and see how we get this out of here. All right, studying this parts explosion and kind of blowing it up a bit. Here's our motor right here. And there's that kind of random bolt that we saw attached to that plate that's welded to the side of the motor. And what we can see actually holds this guy on. They don't really show it that well, but you see part 7 and part 8. And they show you that 7's going through that cast iron frame. And they show you the motor slides up into it. What they're not clear on is that that's actually what's retaining it. It goes through the top part of that welded on bracket. Part 7 and 8, over here on the description, part 7 is a motor rod, and part 8 is an E-ring that holds that. So, all right, we gave this another blowing out so that it's be easier to see, and we also reassembled this switch panel because we didn't need to take that off. Didn't need to disassemble it, rather, in order to get it out of the way. So now, with all this sawdust blown out, we got a really good view of this rod assembly. And this piece down here is actually like a spacer. And the rod comes up, and then that E-clip is right on top. If you zoom in right where my screwdriver is, that's the E-clip that we got to get off. So what I'm going to do to get this going is we're going to have to drive this rod out. So we're going to go ahead and give a little bit of penetrating oil on the top, that for whatever good that might do to soak in there. And then the idea is after we get that clip out, we'll take a punch and we'll try to push this guy through. Now for this, you're going to want to have some eye protection because that little E-clip can go flying. I don't know if I'm going to be able to show this entirely to you guys. I'm going to try to come in here with this little flathead screwdriver first to see how tight this is. I really don't know if it's going to cooperate easily or not. Yeah, I guess it'll come off pretty easy. Just got to get him to snap off all the way here. This particular screwdriver just might not be the best tool to work this off. I brought a pick out here too. I don't know if that's going to, this definitely was not intended to come off, but all right, we got it. We let it fall down there. So now we should be able to drive this through. Let's see. Yep. Okay, we're going to have to turn the assembly over a little bit, but you can see we've already driven it out to here. It's got like a scraping on that side. I still think that's the best direction to drive it out. Almost. My particular punch has gone about as far in as it's going to go. So I'm going to have to find a longer kind of punch tool, but you guys can see in there. Right, so it's serrated at the end. There's where the E-clip went. And so we just got to drive it the rest of the way through over here. Somewhere down here is our E-clip. I was going to fish him out, but I don't see him handy yet. All right, let me get something longer to poke in here, see if we can drive this rod the rest of the way out. All right, because that knurled part wouldn't clear the bottom of the motor, I've gone ahead and drove the pin back through. We're just going to drive it through from this side so we don't have to deal with that knurled part. All right, so you can see we're bringing that knurled part out this end now. I think with that out of the way, we'll be able to get it out. Now what I want to do now is I want to shift this assembly over so we don't have the motor where it's just going to drop. So we'll put it like this. All right, let gravity help us, and then we'll go ahead and drive that pin through the rest of the way. So we're right down here. Much easier. So we should have tried it that way in the first place. So now with that out of the way, we can extract our motor. Still some sawdust on this side. No nameplate. So So we don't know who makes this motor for Sears. No markings whatsoever on it. But at least we can start further diagnosis now. So get a Phillips, we'll take this capacitor cap cover off and we'll inspect the capacitor. I don't know if this is a start capacitor or start and run capacitor. I don't know if this type of motor has a centrifugal switch inside. I'm not seeing any real, like, cooling vents anywhere on this guy. But we can get them apart, right? You can see these nuts. Some of them are kind of rusty, but these 4 nuts correspond to these 4 screws. So one of these end plates, or both these end plates, will come off. It looks like the cooling fan is held on by this clamp assembly here. I was just wearing some gloves in case this thing fell on my hand. Kind of heavy. But anyway, we'll do that and see if we can diagnose whether this is repairable or not. All right, here's the E-clip that we had that goes on this guy here. So it's not a very tight fit. It just keeps it from sliding through once it's under tension. Let's take these 2 Phillips off. And again, we do not have this plugged in. So it's not energized, and it has not been energized for a while. Although you still should treat it as if it is. Well, at least there's some writing on this. 25 microfarad plus or minus 10%, 250 volts AC. There's not physically any damage to this capacitor. Usually they're bulged or cracked, so this one does not look like it's going to be the problem, but we'll go ahead and measure it. I'd have to get it out of circuit in order to measure it, unfortunately, because if we try to measure it in a circuit, we won't get a good reading on it. But that'll be the next step to see if it's the capacitor. I seriously doubt whether it's the capacitor. And if the capacitor tests out good, that means the problem is inside the motor. And there's no reason for us to go any further because you cannot repair these unless it's the type that has a switch inside. So some models, this one looks too small to have it, but some models have a switch near the back here, centrifugal switch, that's supposed to switch off from the starting circuit to the running circuit. That could potentially be an issue, but I'm getting more and more skeptical. But anyway, we'll go ahead and cut this off, test it, see what it is, and we'll go ahead and open it up just for grins anyway. Let's go ahead and take this cooling fan clamp and loosen this guy. And with that loosened up, you should just let go of this shaft, but there might be some corrosion involved. There's always corrosion involved on old stuff. A couple of taps is helping it, though. I don't want to squirt any penetrating fluid in here because this is plastic and it might mess with it, cause it to degrade. But you can see right here, we're just trying to break the seal on this shaft. All right, yeah, we're going to need some kind of help with some penetrating fluid to get in there, but with this out of the way, then we'll be able to take the ends of the motor off. All right, so we're going to put some silicone on this plastic because that won't damage anything with the bushings inside. And then we'll just kind of tap it to get it to work in. Just trying to get some more vibration in here. Try to break the adhesion, have it let go and give us this fan without breaking it. Man, there's so much movement, but it still won't let go. Making sure, yep, that's all there is holding it. And we got lubricant running right down the bottom and out the back. So I guess we just got more corrosion plus sawdust. Or maybe there's a little bit of a bushing in here. Maybe that's the problem. There we go. Just needed a little bit more of a wedge from the screwdriver. All right, so we got that off without anything breaking. Nothing cracked. Good. All right, so we did that because if we want to take this apart, we're going to have to pull these long screws that hold the frame together from these bolts that are on the back. Now these guys we will give a shot to regular penetrating oil, see if it can break up some of the corrosion at the end when we first start trying to turn it. Just trying to do a controlled spray here so we don't get it all over everything, because I would like to clean off some of this sawdust. But I'm not going to spend too much more time on this. I'm thinking that, well, optimistically, I thought, because the motor was running, it might be salvageable. But at this point, I'm doubting it. All right, I don't think there's any way for me to save these kind of factory crimp-on connectors. I'm going to have to cut these off in order to measure the capacitor. Get a meter, get a couple of wire cutters, and we'll see if this is salvageable or if this is a short video. All right, we'll first see if we can just get the factory crimp to let go before we cut anything. So I just really need to separate one of these from the circuit in order to get a measurement of it. This might be on there really too tight for me to do this, but sometimes you get lucky, so it's worth a shot. Yeah, a little bit more. We might be able to separate it like this. Now, why am I doing this? Well, just so we don't cut the wire any shorter than it already is. Right, so we got enough to do the measurement here. All right, that's all I wanted. All right, let's put the capacitor test on here and see. I'm pretty sure this is probably going to be okay, but hey, you never know. You never know. You don't know anything unless you test. Otherwise, it's just a guess. All right, so we'll get one lead here, make sure we're making good contact with the metal of the crimp. We'll put the other on the capacitor. And unless I've got a bad connection, we might have got lucky here. .21 nanofarads. And now, nothing. All right, well, with that, I guess I'm willing to be a little bit more invasive. When I do these pulls, you don't ever want to pull these leads from this resin here because they can break off. So just make sure you support the wire when you're doing that. Nope. Well, that is a bad capacitor, folks. What you should see here is it should slowly charge up to the rated 25 microfarads, but it's not. So we might have just the need for a capacitor. I'm going to see if I have something that's roughly in this range before we waste money buying one that will fit inside of this, just to see if that changes the behavior of the motor at all. All right, we left off with this capacitor being presumed to be a dud. I didn't have anything close to this, so I had to go track one down, and this is what I ended up getting. So 25 microfarads. The voltage is a little higher, but that doesn't matter. What matters is the microfarads. Unfortunately, I could not get something this small. If we take a look at the dimensions here of the original one, we can see that the original one is about 35 millimeters wide and about 60 millimeters tall, which makes it a CBB 60 type capacitor, and that's what this one's rated, CBB 60. But this guy's a little wider at 37. That's not so bad. The problem is he's taller at 73. But if we take a look at our container here, you know, we will, a little bit of plastic flash on this guy, we will be able to get it to fit in here. It's just going to be really cramped for the wiring, so we're going to have to crimp this line down really small to fit in here, but it should work out okay. So now the question is it good? So when we did this test last time, we did the capacitor test. I guess it's about a week has transpired since the previous clip. We determined that when we put this guy on the capacitor test, nothing happens, right? We let it sit, we let it sit, we let it sit, we let it sit, and then he eventually goes OL. But if we take the new one and we do the same test, we let it sit, we let it sit, he charges up to 26.5 microfarads, right? So the rating is 25 plus or minus 5%, so this is a good capacitor. This is a bad capacitor. So definitely a problem there. So what we're gonna do is, rather than open this guy up, because there's no point in opening it up if this doesn't do anything, we're just going to go ahead and see if this made a difference. Now what we will do though is we'll do a quick test of the internal windings. So we're going to get these old capacitor crimp connectors off. We're going to set our meter to measure resistance. We're going to just move some of this insulation off the edge here. Just want to be real gentle with this. Don't want to pull on the inside, and I don't want to have to cut it any shorter than it already is. All right. So what we're going to do this resistance test is we're going to take the two lines that are coming in. We're just going to expose it so we can touch our leads to these spade connectors. Make it a little easier. All right, so first thing we want to do is we want to see if anything's grounded out. So we're going to go from this guy to ground. And actually I'm going to put it on continuity. So if it'll tone if it has a connection. We do not want any tone to ground from either of these. That's good. Nothing shorted to ground. But ground's connected to ground, right? So that's a good test. Now we're going to go back to ohms. And now we're going to measure from this first winding to this input. And we're getting 6.8 ohms, 6.9. And then if we measure to this other input, she's moving on me. Let me get it where she's not moving. This was a little more. I think it's just bouncing around because I don't have it wedged in good. Let's see if it's wedged in good now. Let's just call it 6.7. Now we're going to stay on that same line in and we're going to switch to the other winding. This is what I would expect. One of these is basically almost a straight through wire. And then we're going to switch to this other line in. All right, so I would not have expected both of those to be like that. So we may yet have a problem internally. But we're going to go ahead and try hooking up the capacitor. What I would expect to have seen is from a single phase motor like this, where I believe the capacitor is in series with one of the windings, I would expect to see one straight wire, one resistance value through the start winding with the capacitor, another one with the second winding, the auxiliary winding or the primary, and then one with both. And we didn't really see that total additive number, but we're going to go ahead and give it a shot anyway and see if this changes our behavior at all. So we're going to go ahead and leave this long cable on this capacitor, and we're just going to wire it in temporarily. And we're going to reinstall it inside the housing. We're not going to, put the E-clip on or any of that. We're just going to get it mounted up enough so we can put the belt on and see if we have any change in behavior. So let me go do that, and I'll bring you guys back after I got it sitting inside here. All right, guys, I goofed up in that previous test. That's the reason I got bad results on that second pass. What we've got here is the hot line being broken by the switch. I just had a brain fart. Wanted to test the black coming in from the line, but then also the neutral coming in from the line. So what we should have done is we should have did a test from inside this crimp connector to each of those wires coming out of the motor that are going to go into the capacitor. So if I'd done that, I think we would have been fine. Obviously it works because when we changed the capacitor it tested out, but I wanted to point out that mistake. So what you're going to want to do is you want to take hot to the two pieces of wire that are going to the capacitor, and then neutral to the two pieces, and that's where you're going to get your 3 resistance measurements and your 1 straight shot. All right, we put the motor back in. We didn't drive it in all the way, just enough so it's going to be able to sit. Now we got to adjust the tension. We put the cover plate back on though. We've got the capacitor just kind of sitting in here for now. He'll be okay. Now we're going to come over and put this belt back on. This is the used belt still. This thing starts up. We'll get a new one for it because this one's pretty worn. All right, just like last time. We'll tighten this guy back down until we get the right amount of tension on the belt. Just going to keep turning that lock nut out of the way. All right, that looks like it's about the right way. Tighten that back down. Loosen this. Loosen this. Put this back in the down position. Tighten it back up here. And tighten it back up here. And then we'll see how our belt tension feels. Yes, we got the right amount of deflection, so let's see if the capacitor did anything for us. We'll go ahead and plug it in. Yeah, so it was not the capacitor alone. Trying to make sure that nothing's binding here, because she seems like she wants to turn more. Oh! All right, so this is a different problem. So it was the capacitor, but now I think what we got here is this belt is binding up against the edge. So I think what we want to do is take this back up again and move it back further on the teeth, and we should be good to go here. So we're going to loosen this up again. Alright guys, we just had the camera glitch out on us. All we had done is loosen up this adjustment nut. And so we just want to get some slack on this so we can work it back. So I think that's what's wrong with it. I think it's just binding up here on the edge. Just like that. So we're going to test that theory. Tighten it back down. Like that. Lock it into place again. Loosen it up. Lock it back down again. All right, fixed. So it was the capacitor after all. Kind of surprised about those measurements we got on the windings, but she's working now. So we need to put a new belt on here before we call this done, because this one is really old and cracking, so we can't really send it back to the owner with this. This will be the next thing it breaks, and we already got it all the way apart. These are still made, so these you can get. So I'm going to go put a part number for this down in the description, but I'm going to go ahead and pull this back off again. We'll replace the belt, and then we'll get it reassembled, and we'll see if everything works with it, with a load on it with the full belt and full belt under tension. All right, guys, just to show you the fitment on this new capacitor, you see I cut the leads down so that we can tuck the ends and the little bit of lead that's built into the motor itself. We'll be able to fit them into this little cavity in here, and so this guy will just barely fit, but he'll fit. Again, I put the part number for this one down in the description. Hey guys, just a shot during reassembly here on the motor rod. You want to put your E-clip back on before you drive the rod all the way in, then you can seat it against the ear of the motor bracket. All right, it's been a few more days. We've got our new belt on here to replace the original one. I'll put a link down in the description for this part. It fits just great. And we've got almost everything put back together. As you can see, I went ahead and put the original 4x6 belt on here. It's a 60 grit. It's got a lot of life left on it. And we went ahead and adjusted the tracking. So now it works fine. Now, I had to put this back up and down to do the belt tension. And so you can see this tracking I'll show you over here is off. And I'll show you how we adjust this. So if you move it in this direction, then the belt's going to track that way. And if you move it towards you in the clockwise direction, the belt's going to track this way. And what you want to do is you want to get it to where it's just staying right on the edge. And no squeaking and nice and quiet. Alright, so she's tracking just fine. Some of the squeaking, I think, is just some oil that we need to do up inside one of these pulleys. So we'll give that a shot and see if that fixes it for that. You know, either on this end or this end, there's just no bearing in here. It's just a bushing, and so I suspect one of these is just generating some noise. We'll give that a squirt too. The other thing I found is I did find a copy of the manual for this particular 215-360. So the 215-360 and the 283-290 are identical. They're probably from different suppliers. If we look at the part numbers on the back, what I was mostly interested in is we look at the motor. It's an 8343 725 904, and that's exactly what it is for the other one. And I checked some other parts too. All these part numbers are identical. So this, for whatever reason, it has two different part numbers out there, but this video is going to apply to both, the 283 290 and the 215 360. We went ahead and got the motor fan all back in position. So if I can get this over here where you guys can see. You can see our cover is just going to have a little bit of a gap near the front, and you can see that's just because the capacitor is just a little bit too big and it's going to sit on the ground screw. Unfortunately, if we zoom in right here, you can see that there's just a little gap, and that's just, that's just how it is. There's nothing in this original size. At this point, we can go ahead and put our bottom cover on and tighten up the rest of this and get the rest of this front on here, and then I'll show you a couple more things and we're all done. I'll show you how we got rid of that squeak too. Now, why didn't I open up the motor? Well, when we saw that it actually was the capacitor, and we were kind of discouraged by my messing up this resistance test earlier, when we found it was a capacitor, there's no reason to open this up because the windings are going to be all fine, otherwise it wouldn't be working. The only other reason to open it up would have been if we wanted to swap out the bearings, and we weren't going to do that on this job. So let me get this built back up some more and we'll come back. All right, just a little bit more assembly. We cleaned off all the old sandpaper pieces here, and we'll put a new 6-inch 100 grit disc on here for the owner. Let me show you, we got rid of that squeak by getting some lubricant into the bushing on this end of the roller. And we've got our tracking holding really well. So that took care of the noise, tracking really well. We'll get this on here. Got a couple more things to assemble, and then we'll bring you back when we're all done. All right, guys, we're all done. We've got the last piece of assembly, new paper on here, everything tightened up. Everything's running nice and quiet. So this job's done. I'll give it back to the owner. We didn't spend too much time on it. Just the disassembly piece and trying to research what you needed with the manuals to get it apart. We probably spent at most an hour on this job. I'll put part numbers down in the description for the belt. I'll also put part numbers down, or links rather, that you can find if you need them. These 6-inch sanding discs, these 4x6 sanding belts. I'll go ahead and put a link to the bearings for this motor too, in case you're looking to do that job. But that's it, we're done. If you got questions or comments about what we did today, go ahead and leave them below. I'll try to answer them. If you found this video useful, got your old sander working, helped keep it back on the road and give you some more mileage out of it, appreciate you paying it forward and hitting that like button. And as always, thanks for watching.